Good morning, students. Myself, Chaitra HK, Assistant Professor, Department of Computer Science and Engineering. Today, we are going to know more about the regression topic, which is in Module 4. So, assess core data mining techniques for data analytics. You are going to infer the importance of core data mining techniques for analytics. So, here you have introduction, key steps for regression, then correlations and their relationships, visual look at the relationships, and also regression exercise we are going to look into, and then advantages and disadvantages of regression models. Introduction. Regression is a well-known statistical technique in order to model the predictive relationship between the several independent variables. Right, we have one dependent variable. The objective is to find the best fitting curve for a dependent variable in a multi-dimensional space, with each independent variable being a dimension. The curve could be a straight line or it could be a non-linear curve. So the quality of the fit of the curve to the data can be measured by coefficient of correlation, that is R, which is the square root of the amount of variance explained by the curve. The key steps for regression are simple, like you have list all the variables available for making the model, establish the dependent variable dv of interest, examine visual, if possible, relationship between the variables of interest, find a way to predict your dependent variable using the other variables. Correlations and relationships. Statistical relationships are about which element of data hang together and which one hangs separately. So it is about categorizing the variables that have a relationship with one another and categorizing the variables that are distinct and unrelated to other variables. It is about describing significant positive relationships and significant negative differences. The first and foremost measure of the strength of a relationship is correlation. So strength of a correlation is a quantitative measure which is measured in a normalized range between 0 and 1. A correlation of 1 indicates a perfect relationship where the two variables are in perfect sync. A correlation 0 indicates that there is no relationship between the variables. Relationship can be positive or it can be an inverse relationship. That is, the variables may move together in the same direction or in the opposite direction. Therefore, a good measure of correlation is the correlation coefficient, which is a square root of correlation. This coefficient we call it as a R, which can range between -1 to +1. So an R value of 0 signifies no relationship. An R value of 1 will show perfect relationship in the same direction. And R value with -1 will show a perfect relationship but moving in opposite directions. Given two numerical variables where you have x and y, the coefficient of correlation R is mathematically computed by the following equation x bar. So x bar is the mean of x and y bar is the mean of y. So R is equal to x minus x bar into y minus y bar divided by square root of x minus x bar whole square into y minus y bar whole square. So here we can scatter the plot, which is a simple exercise for plotting all data points between the two variables on two-dimensional graph. So it provides a visual layout of where all the data points are placed in that two-dimensional space. The scatter plot can be useful for graphically initiating the relationship between the two variables. So here you can see the scatter plot showing the types of relationship among the two variables. One is linear and the other one is linear, where we have the y descending towards the x, and then curvilinear, which is similar to an arc shape and where you show no relationship. Regression exercise. So here regression model is described as a linear equation that follows y is the independent variable, that is the variable being predicted. X is the independent variable or the predictor variable. There could be many predictor variables such as x1, x2, like this in a regression equation. However, there can be only one dependent variable y in the regression equation. Y is equal to beta naught plus beta 1 x plus epsilon. So yi is the dependent variable. You have beta naught where it is a population y intercept, beta 1 into xi, which population slope coefficient, where xi is the independent variable, and then epsilon is the random error term. So random error component plus linear component together will get a dependent variable. So see, look into the diagram where you have a simple linear regression. So this we have taken the courtesy from Department of Statistics, ITS, right? So here you can look into the where the intercept happens here, right? Beta naught, and then here we have epsilon. Then here we have this slope. Fine. So we have here the the main idea, multiple regression model, the main idea is to examine the linear relationship between the one dependent, that is y, and two or more independent variables x. So when you have multiple regression model to be built, then y is equal to beta naught plus beta 1 x1 plus beta 2 x2. Like this it goes on, and then you need to add the random error. So this is what a multiple regression equation is. So we'll calculate, see here. Visually, one can see a positive relationship between house price prediction and the size. So, however, when a house price is given and the square root of that house is given, then if they give the square root of the house, then you need to predict the house price. Okay, this is one exercise which is there in your uh, textbook. So relationship between the variables may also be curvilinear. For example, when you are given with the past data of electricity consumption and the temperature, the objective is to predict the electrical consumption from the temperature value. Here we have to have the dozen of observations. So we need to go with the logistic regression model where we have the probability scores as the predicted value of the dependent variable. Logistic regression takes a natural algorithm of the whatever the dependent variable being the case. In order to create a continuous criteria as a transformed version of the dependent variable, thus the logic transformation is used in logic regression as the dependent variable. The net effect is that although the dependent variable in logistic regression is binomial or categorical, that is, it has only two possible values. The logic is the continuous function upon which linear regression is conducted. Here, there is a general logistic function with independent variable on the horizontal axis and also logic dependent variable on the vertical axis. So this is a diagram which shows the logic transformation or logic regression. So here you have the advantages and disadvantages of regression models. So regression models are easy to understand as they are built upon basic statistical principles such as correlation and least square error. Regression models provide a simple algebraic equations that are easy to understand and use. The strength or the goodness fit of the regression model is measured in terms of correlation coefficients and other related statistic parameters that are well understood. Regression models can match and beat the predictive power of weather modeling techniques. So here regression models can include all the variables that one wants to include in the model. Regression modeling tools are pervasive. It means that they are found in statistical packages as well as the data mining packages. MS Excel spreadsheets can also provide simple regression modeling capabilities. So regression models are somewhere inadequate under many circumstances. Like you have regression models which cannot cover for poor data quality issues. Regression models suffer from collinearity problems, meaning a strong linear correlations among some independent variables. If the independent variables have strong correlations among themselves, then they will have to each other's the predictive power, and also the regression coefficients will lose their rigidness, and then regression models will not automatically choose between the highly collinear variables, although some packages attempt to do that. Regression models can be unwidely and unreliable if a large number of variables are included in the model. All variables entered into the model will be reflected in the regression equation. Regression models do not automatically take care of non-linearity. Regression, it means that the user needs to imagine the kind of additional terms that might be needed to be added to the regression model to improve its fit. Regression models work only with numerical data and not with categorical variables. There are ways to deal with categorical variables, though by creating multiple new variables with yes or no value. So we have come to the conclusion part of the regression model topic. Regression models are simple, versatile, visual, graphical tools with high predictive ability. They include the non-linear as well as binary predictions. So regression models should be used in conjunction with other data mining techniques to confirm the findings. So these are the few questions. Discuss regression with example or distinguish between linear and non-linear regression methods. These are the references. Thank you all. Hope you'll enjoy studying this subject.